Hi, everyone. Ms. Bergen. We are now going to be moving on to 6.2, which is just like 6.1. The only difference is now you are subtracting instead of adding. So you still need to find a common denominator still. So I am going to switch this around and we will start this as well. All right, so again, I am not going to be using the fraction strips. So that is, you don't have to worry about that. However, I still want you to write down a couple of notes. Must have a common denominator. First. Okay, and then the next thing that you need to say, when changing the denominator, you must multiply the numerator by the same number 2. Okay, here we go. So we're still going to use common denominator. Again, you could do the quick way of just multiplying those numbers underneath, or just use the multiples of the larger one. You could do that as well. So Mario fills a hummingbird feeder with 3/4 cup of sugar water on Friday. On Monday, Mario sees that 1/8 of the cup of sugar water is left. How much sugar water did the hummingbirds drink? All right, so what it's saying is that he first filled up 3/4, and then he found that only 1/8 was left. So they want to find what the difference was in between here to figure out how much the hummingbirds drank. So can I subtract these fractions as they are? You should be saying no, because the denominators are not the same. So therefore, I always say to look for the largest one, which is an 8. Can I get the 4 to an 8? I sure can. So therefore, I'm just going to change everything to 8ths. Since this one is already in 8ths, I'm just going to slide it on down. But this one, I would have to times it by 2 to both top and the bottom to make it 8ths. So 4 times 2 is 8, and 3 times 2 is 6. So now what this is saying, I'm just going to quickly just show a picture of what it is actually saying here. The picture is going to be of thirds. Eighths. So how you do that? See, do you see how it says 6/8? So how you do that is you go ahead and you cut it up into eighths. Into fourths, and then you're going to cut each of these in half. And if we did it correctly, it should have given us eighths. So 1, 2, 3, 4, 5, 6, 7, 8. Yes, so there's 8 slices. Now, what it is saying is that there are 6 out of the 8 that are here. So 6 out of the 8 are here. So 6 out of the 8 pieces are still remaining. But then what happened was one of them are now gone. So what is left here? So 6 minus 1, if you looked, it would have been 1, 2, 3, 4, 5. So 5 out of the 8 slices total are still remaining. So therefore your answer would have been 5/8. Okay, so that is what you are doing. 5/8 is our answer. Again, you do not have to worry about reducing it. You could just keep it as the answer without reducing. Okay, so then this one, it says now we are going to subtract this. Now it's going to show you with the fraction strips, but just like last lesson, I am not a fan of the fraction strips, so I'm not even going to show it to you. All right, so here we go. This is our subtraction problem. First of all, can I subtract how they are? I cannot, because the denominators are not the same. So in this case, what do I need to do? I need to look at my larger denominator, which is the 6. And I'm going to underline that. Can I get a 3 times something and get it to a 6? I sure can. So therefore, my common denominators are going to be in 6s. 6. So what do I do to a 3 to get it to 6? I times it by 2, and I times the top by 2. So 2 times 2 is 4. So 4 6 minus 1 6. So what is 4 minus 1? It is 3/6. And this is perfectly fine as an answer. Now again, could you reduce this one? You can by doing a common denominator, doing the factor rainbow of the top number, which is 3, so 1 and 3. Can 3 go into 3 evenly? We already know it can. But can 3 go into 6 evenly? And it can't. So therefore, I can divide both the top and the bottom by 3 to make it a reduced fraction. How many 3's go into 3 would be 1. How many 3's go into 6? It is 2. So it's actually a half. So your answer is a half. And then another way of saying a half, just by multiplying both the top and the bottom by 3, still timesing it by 3. 3/3 is still 1 whole. So when I multiply 1/2 by 1 whole, it's still going to give me a half. But this is a different way of saying 1 whole, 3/3. So if I do 3 times 1 is 3, and 3 times 2 is 6. It is still the exact same thing. So these are equivalent to each other. They are the same thing. And that is why I am perfectly okay with you just keeping it like that. So you don't have to worry about any errors messing this number up. And you having the correct answer is perfectly good for me. And don't worry about simplifying it because it is not needed on the state test. All right, so on this one here, what you are going to do is, can I subtract these problems, these fractions? I cannot because they do not have a common denominator. So now I look at my larger one. Can I get a 5 to a 10? I sure can. So therefore, my common denominator is, I'm going to change these all to tenths. Well, since 7/10 is already in 7/10, I am going to just slide it down. But here, what do I do to a 5 to get it to 10? I need to times it by 2. And if I times the bottom by 2, I got to times the top by 2 so that it's 1 whole. So 2 times 2 is 4. So now I can go ahead and subtract. My denominator will still stay the same. What is 7 minus 4 would be 3. So therefore my answer is 3/10. Next, same thing. Can I subtract these fractions as they are? You should have said no because the denominators are not the same. So my larger one is a 4. Can I get a 3 to a 4? I cannot. So now I'm going to go by multiples of 4. 4 times 1 is 4, which we already said 3 cannot go into it. So then 4 times 2 is 8. Can I get a 3 to an 8? I cannot. So now I am going to go 4 times 3, which is 12. Can I get a 3 to a 12? Yes, I can. So therefore, I'm going to change both of these numbers to a 12. So 3 times what will give you to 12? 3 times 4, and then this one would be times by 4. And then what would you do to a 4 to get it to a 12? You would times this one by 3, and you must do the same to my numerator, which is timesing it by 3, because you are still going to times it by 3 over 3, still 1 whole. 4 over 4 is still 1 whole as well. So 4 times 2 is 8. And then this one, 3 times 1 is 3. So now what is 8 minus 3 is 5 over, our denominator still remains the same because there's only 12 slices here. So would have been 5 twelfths. All right, next one. Here, same thing. We cannot subtract because these denominators are not the same. So can I get a 4 to my bigger one? I cannot. So now I'm going to go by multiples of 6. So we already said 6 times 1, which is 6. A 4 cannot get into 6, so I got to move it up. 6 times 2, which is 12. Can I get a 4 to a 12? And you should be saying, yes, I can. So therefore, I'm going to change these all to 12ths. All right, so what do you do to a 6 to get it to 12? Times it by 2, and then this one by 2. 5 times 2 is 10, and then minus, then what do you do to a 4 to get it to 12? You times it by 3, and you do the same to the top. 3 times 1 is 3. So now you just go ahead and subtract. 10 minus 3 is 7 over 12. So your answer would have been 7 twelfths. All right, next one. Again, can I subtract these fractions as they are? You should be telling me no. The denominators are not the same. So my larger one is the 10. Can I get a 2 to a 10? I sure can. So I'm going to times this by 5 to get it to a 10. So I'm going to change these to tenths. So 5 times 1 is 5. And 2 times 5 is 10. So minus, and since this one is already in tenths, I'm just going to slide it on down. So what is 5 minus 3? It is 2 over 10. So therefore, my answer is 2 tenths, which this could be perfectly fine as an answer. Now, some of you might be like, oh, I can reduce that. Because if you did the factor rainbow, you could see 2 can go into 2 and 2 can go into 10. So you could have reduced it by 2. How many 2's go into 2? That would be 1. How many 2's go into 10? That would be 5. So you could have actually reduced it down to 1/5 as well. So one of these two are perfectly fine. To be honest, again, I will just stress, you can just keep it like this. Don't worry about reducing. I'm just showing you how to reduce. But it is not necessary on your homework. All right, next one. Can I subtract these fractions? You should be telling me, no, I cannot. So therefore, now I got to find a common denominator for these. My largest one is an 8. Can I get my 4 to an 8? And yes, I can. So I am just going to change these to 8ths. Well, since this one is already an 8ths, I'm just going to slide it on down. It is still going to remain 3/8 minus. Now, what do I do to a 4 to get it to an 8? Times it by 2, and I must times the top by 2. 2 times 1 is 2. So what is 3 minus 1? I can now subtract because my denominators are the same, so that denominator will still remain the same. Then 3 minus 2 is 1, so therefore my answer is 1/8. Next, here, can I subtract these fractions as they are? I cannot, because the denominators are not the same. So therefore, I'm going to be looking at my larger one, which is a 3. Can I get a 2 to a 3? I cannot. So therefore, I need to do multiples of 3. So 3, I already know, cannot. So 3 times 2 is 6. Can I get a 2 to a 6? I can, and I can get a 3 to a 6. So therefore, a common denominator for both of these is changing them to 6. So what do I do to a 3 to get it to a 6? I gotta times it by 2, and I must do the same to my numerator. 2 times 2 is 4, so that one is 4. Then here, what do I do to a 2 to get it to a 6? Times it by 3, times it by 3. So 3 times 3 is 3. So now I can subtract. What is 4 minus 3 is 1 over 6. So therefore, your answer is 1/6. All right, now I want you to try doing 7, 8, and 9 on your own. Again, try this on your own. Please pause the video and do 7, 8, and 9. All right, so you should have done 7, 8, and 9 and pause the video. And if you did, this one would have been 3/10, which you could, if you would have changed everything to tenths. This one you should have changed everything to 12ths. And when you subtracted, it would have been 1/12. And then you should have changed all of these to tenths. And then when you subtracted, it would have been 1/10 as an answer. All right, so now I'm going to come over here. This one says the shaded part of the diagram shows what Tina had left from a yard of fabric. She now uses 1/3 yard of fabric for one project and 1/6 yard for a second project. How much of the original yard of fabric does Tina have left after the two projects? All right, so on one project, she used 1/3, and the other project she did 1/6. So what they want you to do is figure out how much she used total. So what we're going to do is we're going to add these. All right, so can I add these fractions? I cannot, because the denominators are not the same. So I look at my larger one, which is 6. Can I get a 3 to a 6? I sure can. So I'm going to times it by 2 and 2. So I'm going to change these to 6, which is 3/6. All right, so 3/6 have been used so far. The question is, how much of the original yard of fabric does Tina now have left? Well, if this is 1 yard, so 1 yard minus what was used, which is 3/6. All right, so here's the problem. We have 1 minus 3/6. The issue with this is that we have a whole, but how can I make this whole be so it looks like this as a denominator? It has the same denominator, which is a 6. So how do you make this still say 1 whole so that it is written as a fraction but has a denominator of 6? So remember, when you're making 1 whole, in order for it to be 1 whole, it would have to have the same numerator on the top as well. So same numerator and denominator. How many 6's go into 6? That is 1 whole. So this is just a different way to say 1 whole. All right, now can I subtract this? Yes. So 6 minus 3 is 3 over, and then my denominator still remains 6. So my answer could have been 3/6. If you reduce this down, you could have reduced it by 3 to both sides. Again, you don't need to do this. I'm just showing you how many 3's go into 3 would be 1. How many 3's would go into 6? That would be 2. So you could have also said a half. So either of these two would have been correct. All right, next. The next problem is this one. It says, the picture at the right shows how much pizza was left over from lunch. Jason eats 1/4 of the whole pizza for dinner. write a fraction that represents the amount of pizza that is remaining after dinner. All right, so here's the thing. This is what was left, but they said that he ate 1/4 of the whole pizza. Well, what is 1/4 of the whole pizza? If this was an entire pizza, what is just 1/4 of it? 1/4 is actually 2 slices. So if you come over here, it says Jason eats 1/4 of the whole pizza. How many slices did he eat then? Well, that would have been 2 slices. So in order to do this, they want to know how much pizza would be left. Well, what was there? So 1, 2, 3, 4, 5 out of 1 out of 8. So that would be 5/8 were remaining. So it says, what is the remaining pizza after he eats his dinner? So far there's only 5/8 still left for him to eat, but it said he ate 1/4, which is 2 slices. So you could have just have said, okay, could have said minus 1/4, which if you did this and made a common denominator, you could have just did 2/8. So what is 5 minus 2 is 3/8. So therefore 3/8 of the pizza would be left. This next question, the only one that I'm really worried about is this one down here. I just want to know this part of the question. I'm not a fan of this problem. So if you come down here, it says they want to know whether the fractions 3/4 and 6/8 are equivalent. So they're asking, is 3/4 and 6/8 the same? Now, how do I go about finding out whether they are the same or not? My advice to you is to first find a common denominator of both, and then see if it is possible that they be the same thing. So my largest one is 8. So can I get a 4 to an 8? I sure can. So I'm just going to slide this down because this one is already an 8. Now I'm going to change this one to 8. What do I do to a 4 to get it to 8? I should times it by 2 and do the same to the top. So if I do the same to the top, it would be 3 times 2, which is 6. So is 6/8 and 6/8 equal to each other? Yes, they are. They are definitely equal to each other. So therefore, this is a true statement. Also, what you could have done is you could have reduced this by dividing 2 on both the top and the bottom to get 3/4. So that is just another way that you could have saw whether these are equivalent to each other. All right, so the next part of this is, again, you are going to say find a common denominator first, and then you can solve. All right, so your homework for today will be 2, 4, 5, 7, 8, and I'm going to give you 11. And I'm going to do these ones with you. All right, so very quickly, can I subtract these fractions as they are? You should be saying no, because the denominators are not the same. So look at the larger one, which is an 8. Can I get a 2 to an 8? Yes, I can. So I am going to say, okay, I'm going to change these to 8s. Since this one is already in 8s, I do not need to change anything. That just brings on down. Then here, what do I do to a 2 to get it to an 8? I need to times it by 4, so I must do the same to my numerator as well, so that I am still multiplying by 1 whole. So 4 times 1 is 4. So therefore, now that they have this same denominator, now I can subtract, and that's still going to give me out of 8 slices. So I had 7 slices and to begin with, and then I ate 4 more. So how many are, and now I ate 4, so there were 7, and then I ate 4, so how many are left? 7 minus 4 is 3. So therefore my answer would have been 3/8. Also, just a reminder, take out all of this. You don't have to worry about simplest form, and you're not doing the fraction strips. All right, now here, can I subtract these as they are? You should be saying no, because the denominators are not the same. So therefore, look at the larger one. Can I get a 2 to a 5? I cannot. So now I'm going to go by multiples of 5. So 5 times 1 is 5, which we already said 2 cannot go into. So then 5 times 2 is 10. So can I get a 2 to a 10? I certainly can. So therefore, the one that will go into both 5 and 2 is 10. So I'm going to change these to tenths. So how do I get a 5 to a 10? I times it by 2, and I do the same to the top. 4 times 2 is 8. Then how do I get a 2 to a 10? I times that by 5, and I do the same to my numerator. 5 times 1 is 5. So what is 8 minus 5 is 3/10. All right, next. Again, can I subtract them as they are? Again, you should be yelling at me and saying no, because I've said it so many times. You need to have a common denominator. So in this case, you look at your larger one, which is a 10. To save time, can I get that 2 to a 10? I certainly can. So therefore, a good common denominator would be tenths. Well, since this one is in tenths already, I am just going to slide that on down. What do I need to do to a 2 to get it to a 10? I need to times it by 5, and this one by 5. 5 times 1 is 5. Now I can just simply go across. This is now going to be a 10. 7 minus 5 is 2, and this is perfectly okay as an answer. You can keep that as your answer. Some people might be like, oh, but I see that 2 can go into both 2 and 10. And you are right. This could be reduced down by 2 to both top and the bottom. So how many 2's go into 2 would be 1, and how many 2's go into 10 would be 5. So 1/5 as well. So you could have said either of those two. Again, this is all I truly need you to do is this one. You do not need to go the extra step there. Now I'm going to do this one with you. Amber had 3/8 of a cake left after her party. She wrapped a piece that was 1/4 of the original cake for her best friend. So what fractional part did she have left for herself? So what you are going to do is you're going to take 3/8 and then you're going to subtract off 1/4 of that. So if you do this, and I really don't like this wording because I would be thinking 1/4 of the whole cake. So it gets really confusing how they word it. So just be very careful of that. So what they wanted you to do is do 3/8 minus 1/4. So you cannot subtract this because the denominators are not the same. So my biggest one is an 8. Can I get a 4 to an 8? Yes, I can. So therefore, I'm going to change these to 8ths. Since this one is already an 8ths, there is nothing to change. What do I do to a 4 to get it to an 8? I times it by 2. And I times the top by 2. 2 times 1 is 2. So then 3 minus 2 is 1 over my denominator still remains the same. So it'll be 1/8 of the cake. All right, so that is that page. Now I'm going to go over to the next page. What I want you to do here is 1. I'm going to do number 2 with you. Hannah bought 3/4 yard of felt for her project. She used 1/8. What fraction of a yard of felt did she have left over? So all you had to do here is she had 3/4, then she used, which means subtracted off, 1/8 of it. Again, can I subtract these fractions as they are? You should be saying no, because the denominators are not the same. So look at the larger one, which is an 8. Can I get a 4 to an 8? I sure can. I can times it by 2 and this one by 2. So this would now be 8, and the top would be 6 minus 1/8, because that's already an 8th. So I'm just sliding it on down. 6 minus 1 is 5 over our pizza's slices, which is 8. So our answer is 5/8 of a yard. Okay, you will have 3. You are going to cross out 4, and you will do 6. Now this one I'm going to do with you. It says during the day, Sam spent $4.85 on lunch. He also bought 2 books for $7.95 each. And at the end of the day, he had $8.20 left. How much money did he start out with? All right, so in order to do this, you actually got to work backwards. So it's saying everything that he had spent or had left over. And then in order to find this, we would have to add up all of this to figure out what he started with to begin with. So you are going to have $8.20 left over. So that is what you are starting with. Then you are going to be adding in the 2 books that are $7.95 each. So that was just for 1, but he bought 2 books. So you're going to have that twice. And then he spent $4.85 on lunch. So in order to do this, you should have added these, making sure the decimals are all lined up. 5 plus 5 plus 5 is 15. Carry your 1. When you add this, let's see. So this is 18 plus 1 is 19, and then plus 10 is 29. So a 9, carry your 2. And then this one would be 15 plus, so 15 plus 11 plus 2 is 13. So that would be 28. So therefore, Sam started off with $28.95. And that would have been your answer on that one. Okay, so then this is 6.2 for homework. All right, talk to you guys later. Bye.